So, we've all gotten pretty used to AI that can chat, right? But today, we're going to talk about something way bigger. We're talking about the incredible leap from an AI that just thinks to one that actually does. Let's get into it.
Really think about that for a second. We've all been wowed by chatbots for sure, but the real game changer, the real revolution, is when these powerful digital brains can actually look at the world, use tools, and, take action for us.
All right, so to understand how we get to an AI that acts, we first got to look at the engine driving all of this, the large language model, the LLM. It's like a brilliant brain, no doubt. But, and this is a big but, it's got some serious flaws. And here's the fundamental problem, right? On one hand, an LLM is a phenomenal text predictor. It's been fed a massive chunk of the internet, so it gets language, it gets nuance, it can even write code pretty well. But the flip side is that all its knowledge is stuck in the past. It's frozen at the moment its training ended. It has no idea what happened yesterday, let alone 5 minutes ago. So you can't really trust it to be an expert on anything current.
And that leads to its other huge weakness. Its memory is, well, it's shaky. LLMs can hallucinate, which is a fancy way of saying they just make stuff up and state it with complete confidence. And there's an even scarier problem lurking, this idea of model collapse. If you keep training AIs on the stuff that other AIs have written, they can start to forget the real world, kind of like a photocopy of a photocopy getting blurrier and blurrier.
So what we have is this absolutely incredible brain that's basically locked in a box. It's completely isolated, with no connection to the real live world, and a memory you just can't count on. To make it truly useful, we have to find a way to break it out of that box. Okay, so how do we do that? How do we fix this isolated brain? Well, the very first step is to give it a much, much better memory. One that's external, always up to date, and crucially, perfectly searchable. And that brings us to the first major piece of the puzzle, a technique called Retrieval Augmented Generation, or just RAG. You can think of RAG as giving the AI a library card. But not just any library card. It's a card to a library that's constantly updated with the latest, most factual information. And the way it works is actually pretty straightforward. You ask the AI a question. Before it even tries to answer, the system does a quick search in its external knowledge base, say a database of news articles or your company's internal documents, and pulls out the relevant facts. Then it hands those facts, along with your question, to the LLM. All of a sudden, the LLM has fresh, reliable context, and it can give you an answer that's actually grounded in reality. But we can make this memory even more powerful. Enter the knowledge graph. Now, instead of just storing a bunch of separate documents, a knowledge graph actually understands relationships. It doesn't just know Paris and France. It knows that Paris is the capital of France. It knows the Eiffel Tower is located in Paris. It's a web of connected knowledge, not just a pile of facts. And this is a really key difference. See, standard RAG finds text that sounds similar to what you asked. It's looking for semantic similarity. But GraphRag, which uses these knowledge graphs, it's different. It follows the connections between ideas. It lets the AI answer way more complex questions because it can actually trace how things are linked together, just like we do. Okay, so our AI has a great memory now. It can tap into up-to-date info and understand how it all connects. That's huge. But how do we get it to actually do something with that knowledge? This is the moment we jump from just knowing to actually doing. And for that, we need to meet the AI agent. Now, an agent is way more than just an LLM. It's a whole system built around that LLM brain. It's a system that has a brain for thinking, senses for perceiving the world, and hands for taking action. Let's break that down real quick. The brain, that's the LLM. It does the thinking, the planning, the reasoning. Then you have perception. These are the agent's senses, letting it pull in data from text, from images, from anywhere really. And finally, you have action. And this is the game changer, the ability to actually use tools to get things done. So what are these tools? Well, it's pretty much anything the agent can connect to. It could be a simple calculator to solve a math problem. It could be a web search to check live flight prices. It could even be another, more specialized AI that's great at analyzing images. These tools are what give the agent hands to interact with the digital world. And look, this isn't just theory or science fiction.
This is happening right now. Developers are using powerful toolkits like LangChain, AutoGen, and a bunch of others to build really sophisticated AI agents today. The revolution is already being built.
So, you put it all together. You take these powerful brains, give them perfect memories, and a whole toolbox of capabilities. What do you get? You get a completely new way of getting work done. You get the agent revolution.
Now, a single agent on its own is already a huge deal. It can automate some really complex stuff. But if you give a truly massive problem to just one agent, it can get overwhelmed. The real magic, the next level, is when they start working together.
Check out this example, a system called ChatLaw. Instead of one AI trying to be a lawyer, it creates a whole team of specialists. You've got one agent that just gathers info. Another one digs through legal documents. A third one acts as the legal advisor, and a fourth one writes up the final report. Each one is an expert in its little piece of the puzzle.
And that right there, that's the paradigm shift. We're moving from one general-purpose AI to these collaborative teams of digital experts. And that allows for a kind of complexity and depth that a single agent could just never pull off on its own.
Let's make this super relatable. Imagine you want to plan a trip. Instead of you doing all the work, an agent system could do it. You'd have a weather agent that checks historical data to find the best week to visit, a hotel agent finds places you'd actually like, an itinerary agent plans out the fun stuff, and a summary agent pulls it all together and drafts the perfect email for you. A whole team working together just for you.
And this potential it's just massive. We're talking about applying this team-based approach to some of the biggest challenges humanity faces. There are already systems creating teams of agents to speed up scientific discovery, to design new chemicals, to analyze incredibly complex biological systems. It's truly transformative.
Which, of course, leaves us with the big question. When these AI agents can work together, create and manage complex projects all on their own, what does that mean for us? What's our new role? The thing is, the human doesn't just disappear from the picture. Our role just evolves. We shift from being the doer to being the director, from the worker to the visionary. And figuring out exactly what that looks like, well, that's the next great frontier we're all just starting to explore.